Hello everyone. Today in this class we'll have a discussion on measurement of inductance and capacitance. We'll see first one, measurement of self-inductance. Okay. So in the previous class we had a discussion on AC bridges and sources detectors. Normally AC sources are applied for these bridges. Okay. In that first one we'll have measurement of inductance by Maxwell bridge. The previous class what we discussed, AC bridges, the bridge is balanced when no current flows through the terminal B and D. Okay. So when there is no terminal here B and D, here B and D, the bridge is balanced. So once it is balanced, we have the equation Z1 Z4 equals to, it is Z2 Z3. Okay, where Z1 indicates the impedance of this arm and Z4 indicates the impedance of this arm. The product of impedance of one pair of opposite arms must be equal to the product of the impedance of the other pair of the opposite arms. Okay, so first pair is Z1 Z4 and second opposite arm is Z2 and Z3, where Z indicates the impedance of that branch. Okay, so today we'll have the measurement of this inductance L1 by Maxwell bridge. This is Maxwell bridge. Sorry. Maxwell bridge. So Maxwell has introduced this bridge network for finding the unknown inductance. We know that the inductance is being represented as like this. Okay, it's terminal 1 and it's terminal 2 inductance. So once for inductance, it has small resistance also. It is represented as small r. Okay, so here the first arm AB has an impedance of, it has an impedance consisting of resistance R1 and L1. So both are connected in series. So this we need to find by making bridge under balance condition. Okay, first arm is having the resistance R1 and L1. Just remember this bridge network. Okay, and second arm is having the impedance R2 and L2. So R2 is a variable resistance connected in series with this inductance. Okay, both are variable. So R2 is variable resistance, and as well as L2 is also variable inductance of, and it has a fixed resistance of R2. Remember, small r2. Okay, so R2 and L2 are connected in series, and this unknown variable inductance has a fixed resistance of small r2. So this is what the second arm. Whereas the third arm is having the resistance R3. R3 is the known non-inductive resistance. It is purely the known resistance. We know the value of R3. And last arm is also having the resistance, pure resistance R4, which is non-inductive resistance. Okay, all these impedances are connected in this bridge fashion, and the terminal A and C are connected to low voltage high frequency AC supply. So here the value of the inductor as well as capacitor are dependent on the frequency term. Okay, if you have the inductance, its inductive reactance is represented as XL. So this inductive reactance is given by 2 pi into FL. Okay, where F is the frequency, L is the inductance. Okay, and this frequency depends upon the inductive reactance. Okay, for capacitance, its inductive capacitance is represented as 1 by 2 pi into Fc, where C is the capacitance in terms of farads. Okay, so first thing is that we need to maintain the bridge under balance condition. So how to maintain the bridge under balance condition? By varying the value of resistance, standard resistance R2 and standard variable resistance L2. So we have to vary these values until there should not be the flow of current between the terminals B and D. So once the current is 0, so then look at the value of resistance and L1. Find the value of R1 and L1 by using this equation Z1 Z4 equals to Z2 into Z3. Okay, so before finding the value of R1 and L1, we'll write the values for Z1, Z4, Z2 and Z3 first. So then we'll find the values of resistance R1 and inductance, unknown inductance L1. Okay. So what we have for when the bridge is balanced, Z1, Z4 equals to Z2 into Z3. Okay. Right. So Z1 is given by impedance of first arm. Impedance of first arm impedance of first arm is given by first arm is represented as Z1. I will let Z1 as Z1 equals to, it is a combination of resistance and inductance. Resistance is connected in series with the inductance. We need to represent inductance in terms of its inductive reactance. So R1 plus, I will write the inductive reactance of first inductance as J omega L1, where omega equals to 2 pi f, remember, or you can write 2J XL. Okay, in terms of omega also you can write. So Z1 equals to R1 plus J omega L1. This is the value of first impedance. And Z4 last arm is, it is having only the value of resistance, so let it as R4. There is no inductance or there is no capacitance, its inductive reactance is 0. So next is Z2. Z2 equals to, it is a combination of resistance as well as inductance. So we'll write for purely resistance it is R2, and inductance it's J omega L2, and this inductance has a small fixed resistance. I will write it as R2 plus small r2. Right. So we got Z1, Z4, Z2, and the remaining arm is Z3. Z3 is having only the pure resistive, non-inductive resistance. I will write it as R3. Okay. So we got the values of impedance of all the four arms. So by balance equations, find the unknown resistance. Okay. When the bridge is balanced, so what we have, Z1, Z4 equals to, it is Z2 into Z3. Okay. So we know the value of Z1. Z1 is R1 plus J omega L1, and Z4 is this one R4. So multiplied by R4 equals to Z2 is this thing complete second arm resistance R2 plus J omega L2 plus small r2 into Z3 is R3. Okay, so here in this equation, look at the bridge network. The only the unknown quantity is R1 and this one, R1 and L1. So we know the value of R2, L2, small r2. We know the value of resistance R3 and R4. By varying the standard resistance, inductance, and standard resistance R2, we can make the current 0 between the terminals B and D. Okay, so here multiply the terms here. So what we are going to get, solve this equation. It's R1 R4 plus R1 sorry R4 j omega L1. Left hand side is over. Next thing is R2 plus small r2. I will rearrange this equation. R2 plus small r2 plus j omega L2 into R3. Okay. Hence R1 R4 plus R4 j omega L1 equals to multiplier R2 plus small r2 multiplied by R3 plus j omega L2 into R3. Okay. So left hand side equation we have R1 R4 plus R4 j omega L1. Right hand side equation we have R2 plus small r2 into R3 plus j omega L2 into R3. So next is equating the real and the imaginary terms. Equate the real and imaginary terms. So what we'll get? So in the left hand side equation, real term is R1 R4, that has to be equated with this term R2 plus small r2 into R3. We'll write here real term. So what we have, R1 R4 equals to, it's R2 plus small r2 into R3. Okay, we know the value of R4, we know the value of R2 plus small r2 into R3. The only unknown quantity is R1. So R1 equals to R2 plus small r2 into R3 divided by R4, resistance R4. So we got the value of R1. So imagine, let us equate the imaginary term. What we have? Second term. This has to be equated with the right hand side equation. So we'll write direct equation, that is R4, j will get cancelled, omega L1 equals to omega L2 R3. Okay, the unknown quantity is L1. So L1 is given as omega L2 R3 divided by R4 into omega. Omega will get cancelled. The value of L1 is R3 by R4 into L2. This is the value of inductance L1. So when the bridge is balanced, this Maxwell bridge will give the information about the unknown inductance L1 as well as unknown resistance R1. Thank you.